So carrying on from the cubic graphs, we're now going to be looking at the quartic graphs. Now a quartic function is in this case here, where now we have an x to the power 4 term like this. The general shape of a quartic graph will look a bit like a W shape. And if I was to have a negative quartic function, like a negative x to the power 4 function, then we just reflect it in the x-axis like so. Right, so like the cubic function, you just have to follow a number of steps. So first things first, is it a positive coefficient or a negative coefficient? Second step, find where it crosses the y-axis, just x is 0, plug it in. And the third step is finding where the roots are. Now, like the cubic one, depending upon the number of roots and the type of roots, then it's going to change the shape up slightly. But we just have to follow this general rule, right? If it's a repeated root where the repeated ones are even numbers, like squared to the power 4 to the power 6, then it's just going to touch the x-axis. If it's repeated but with odd numbers, like cubed to the power 5 or to the power 7, then in that case, it's going to cut. Right, so let's look at an example. So first things first, let's look at a simple one. Y is equal to x minus 2, x minus 1, x, 5 minus x. So we know the roots are going to be at x is 0, 1, 2, 5. It's a positive x to the power 4 coefficient, and it crosses the y-axis at 0. So now just draw the general shape like a W, like so. You guys try this question here. Right, so first things first, we need to find the roots. So this term here, we can factorize to x minus 3, x minus 2. So we know the roots are going to be at minus 2, 1, 2, and 3. It's going to cross the y-axis at y is negative 12. And it's also, once again, a positive x to the power 4 coefficient. So it's going to look like a W. And if you just sketch it, it will look something like so. The second example is when there are going to be 3 roots. So basically, we have 1 repeated root and 2 unique roots. So an example would be like so. At x is 1, it's going to be repeated. So we know that it's just going to touch the x-axis, not cut it. Whereas when x is negative 2 and negative 5, it's going to cut the x-axis. And so it's going to look something like this, with the x to the power 4 coefficient being a positive. Once again, pause the video here and try this question here. Right, so let's try this example here. So we know it's got a repeated root at x is 0 and unique roots at x is 4 and 7. So at x is 0, it's going to touch the x-axis, whereas when x is 4 and 7, it's going to cross the x-axis. We also notice that it's a negative x to the power 4 coefficient due to this term here, and therefore it's going to look something like this, more like an upside down W. The next case is when we have 2 repeated roots. So for example, y is x minus 2 squared and x plus 5 squared. But once again, it's the same logic. When it's repeated, it's just going to touch it. So it's going to touch the x-axis at x is 2 and negative 5. Once again, it's a positive x to the power 4 coefficient, and it's going to cut the y-axis at y is 100. And so it's going to look like a W shape in this form. Right, so let's look at this one here. So it's a triple repeated root at x is 1, is going to be cut the x-axis, and when x is 5 is also going to cut the x-axis. It's also a negative x to the power 4 coefficient, so it's going to be reflected in the x-axis and look something like so. Try this question here. Hopefully you got this graph here. So it's got a triple repeated root at x is 2, and it cuts the x-axis at x is 8, and it crosses the y-axis at y is 64, and so it will look something like this. The x to the power 4 coefficient is positive, right? Because you just have to multiply the x terms, and so that's why we get this shape here. Right, so for the last variation, it's going to be a quadruple repeated root. For example, y is x minus 1 to the power 4. In this case, because the repeated root is an even number, it's just going to touch the x-axis rather than cut it. So it's going to touch the x-axis, in this case, at x is 1. Now the general shape, rather than a W, is actually going to look more like a U. So just be aware of that in this particular case. So those are all the main different types of variations depending upon the roots. Now there are some more less conventional ones, for example, this question here. In this case, once again, if I was to find the discriminant of this quadratic term here in this bracket, it's a negative number, so there's no solutions, meaning there's only going to be 2 unique roots. Now in this particular case, what you really want to do is understand where it crosses the x-axis, where it crosses the y-axis, and then imagine to yourself what happens when x gets very small or when x gets very big. You can do this by just plugging in small x values and large x values and just seeing what the y values are going to be, and then making sure you just follow the general shape. The shape itself is not too important, it's just more the fact that you know where it crosses the roots or if it even crosses it, and also the fact that is it a positive x to the power 4 coefficient or a negative x to the power 4 coefficient. So these are all the variations of a quartic function graph. as I said, it's a lot of different variations depending upon the number of roots. And so if you just follow the general steps and the general rules, then hopefully you can draw most quartic functions. It does take a lot of time and practice. I've listed out a couple of different types of quartic function graphs that you guys should practice after this video.